Hi, we will learn how to draw an ellipse by eccentricity method. The problem statement is draw an ellipse when the distance of its focus from its directrix is 50 mm and eccentricity is 2 by 3. Also, draw a tangent and a normal to the ellipse at a point 70 mm away from the directrix. The first step in drawing an ellipse is to draw the directrix at a convenient position in the drawing sheet. So use the vertical scale of the mini drafter and draw a vertical line D dash D, the directrix. Draw a horizontal line using the horizontal scale of the mini drafter and name the line as AB. After drawing the directrix and the major axis AB, mark a point F, that is the focus, on the major axis AB at a distance of 50 millimeters from the directrix. The data 50 millimeter is given in the problem. In order to locate the vertex, we need to add the eccentricity numerator and denominator values. If you add 2 and 3, we get 5. Now divide AF into 5 equal parts. Why 5? Because 2 plus 3. What is this 2? Numerator of the eccentricity. 3 is the denominator value of the eccentricity, is equal to 5, and division of AF into 5 equal parts looks like this. We know eccentricity E is equal to V1 F divided by A V1. F is the focus, A is the point here, starting of major axis, and V1 is the vertex. Already we know AF. The only unknown is V1 in this eccentricity relation. So what is that eccentricity? Distance of a point from the focus divided by the distance of the point from the directrix. So this E value is given as 2 by 3. So what we infer is distance between V1 and F is equal to 2. Distance between A and V1 is equal to 3. Therefore, from F, point F, mark point V1 after two divisions like this. So V1 is the vertex. Distance between the vertex and the focus is equal to 2. So 2 divisions. The distance between the vertex and point A is equal to 3. So automatically it comes 1, 2, 3. For an ellipse, there are two vertex and hence we used the symbol V suffix 1. Where is the other vertex? We need to locate. We will discuss that procedure now. After obtaining V1, draw a line perpendicular to AB through V1. Already there is a vertical line through V1. Now with V1 as center and V1F as radius, draw an arc and obtain point E. So V1 as center, V1F as radius, draw an arc until the arc intersects the vertical line through V1 and that intersection point is E. The next step is to join AE and extend it. So AE is joined and it is extended. Now from F, draw a 45-degree line to obtain C. How to draw the 45-degree line? Make use of the mini drafter and 45-degree set square like this. Draw a line and obtain point C. So where is this point C? Point C is the intersection of 45-degree line from point F and AE extended. So this angle is 45 degree. From C, draw a line perpendicular to AB and obtain the second vertex V2 like this. Now the vertices of the ellipse are drawn on the drawing sheet. Now divide the distance V1 and V2 into number of equal parts or number of points at equal distances. Through each point, draw lines perpendicular to AB till they intersect the line AE extended. So like this. The distance between the point V1 and V2 are divided into 12 equal parts or equal points. Through each point, a vertical line is drawn both above and below AB, and the points are obtained like this, where this first vertical line intersects AB is point number 1, second point is F itself, 3, 4, 5, 6, 11, and the 12th point is V2. Similarly, these vertical lines intersect AE extended at 1 dash, F dash, 3 dash, 4 dash, 11 dash, and of course you can take that as V2 dash, which is not shown here. Now measure the distance 1 1 dash using a compass. With F as center and 1 1 dash as radius, draw an arc to cut 1 1 dash at P1 dash like this. So F as center, radius is 1 1 dash, draw an arc and obtain point P1 dash. P1 dash is obtained here. Similarly, obtain point P1. How? With the F as center and 1 1 dash as radius, draw an arc cutting the line 1 dash 1 produced below AB. 1 dash 1, this is a vertical line, and that vertical line is produced or extended below AB. On that line, draw an arc and obtain point P1. Next, measure the distance F F dash using a compass. With F as center and F F dash as radius, cut an arc on the line F F dash. The arc will coincide with the point F dash. Therefore, it is not shown here. We need to obtain the point P suffix F. For that, again, with F as center and F F dash as radius, draw an arc on the line F dash F produced below AB like this and obtain P suffix F. So this point is P suffix F. Follow the similar procedure to obtain two points on all the remaining vertical lines. Now measure 3 3 dash and obtain points P3 and P3 dash with F as center. So measure 3 3 dash, F as center, cut an arc and obtain P3 dash. Again with F as center, 3 3 dash as radius, cut an arc and obtain point P3. Similarly, we need to obtain points on the vertical line 4-4. Measure 4 with the FS center. 4 is radius. Cut an arc. Obtain P4 dash. Similarly, obtain P4. The same procedure is followed in point 5 also, or not point 5, on the line through 5 also. Measure 5 dash with the FS center and 5 dash is radius. Draw an arc, obtain P5 dash, and similarly at the bottom obtain P5. The letterings are not shown here. That means the points P5 dash and P5 are not shown here. Similarly for 6, measure 6 dash, FS center, cut an arc and obtain points P6 dash and P6. Similarly for 7th vertical line, measure 7 dash, FS center, cut an arc at the bottom with the FS center, 7 dash is radius, cut an arc. Similarly for a line through point 8, measure 8 dash with the FS center, cut an arc, obtain point P8 dash, and below AB line obtain point P8. Measure 9 dash, FS center, cut an arc above and below. Measure 10 dash, FS center, cut an arc above and below AB. Measure 11 dash, FS center, cut an arc and obtain points. V2 is the vertex. Look at the drawing. Already obtained points by cutting arcs are shown in red color just for easy visualization. Now we name these different cutting points. P1 dash, F dash, P3 dash, P4 dash, P5 dash, P6 dash, P7 dash, P8 dash, P9 dash, P10 dash, P11 dash, V2. Similarly at the bottom P11, P10, P9 up to P1, and here it is V1. We have now 24 points on the 11 lines 1 to 11. We have 2 points each. Therefore 11 into 2, 22. V1 23rd point, V2 24th point. Now we need to join all these points by a smooth curve to obtain the ellipse. Smooth curve is drawn like this. So the ellipse is drawn. If you look at the drawing, only the ellipse is bright or it is thick. All other lines are thin. Use 2H pencil to draw the thin lines and H pencil to draw the ellipse. The ellipse is drawn. The final step is to draw a tangent and a normal to the ellipse at a point 70 mm away from the directrix. For that, mark a point P on the ellipse at a distance of 70 mm from the directrix. Point P. Use a scale or a protractor and join points P and F. P and F are joined. After that, draw a line from F perpendicular to PF. How to draw that perpendicular line? One method is coincide the longest edge of a 45-degree set square with the line FP, and but the shortest edge of a 30-60 set square to the 45-degree set square as shown. Now from F, draw a line, and that line is definitely 90 degrees, and obtain point T on the directrix D dash. So point T is obtained on the directrix. Join T and P like this. So this blue color line is the tangent through the point P, which is at a distance of 70 millimeters from the directrix. Draw a line perpendicular to TP through the point P like this, and that is the normal. So this completes the problem. Thank you.